You know that phone in your pocket? Or the laptop on your desk? Ever stop to think what's actually inside them? Well, today we're going to pull back the curtain and go inside the hidden factory that lives within our favorite gadgets. We're going to witness this incredible high-speed robotic ballet that builds the electronics we all use every single day. Okay, so at the very heart of, well, pretty much everything you own these days is a circuit board. You really got to think of it like a miniature city, just jam-packed with tiny electronic components. It's the brain, the nervous system, it's what makes modern tech tick. But here's the crazy part, right? How in the world are these super intricate little cities built? And not just built, but built with perfect precision, at a speed and a scale that's, honestly, it's almost hard to wrap your head around.
Well, for a long, long time, the answer was people. Human hands meticulously placing every single tiny part. But, as our tech got smaller and way, way more complex, doing it by hand just became this massive bottleneck. It couldn't keep up. And when you put them side by side, it's really night and day. On one side, you've got manual work. It's slow. And let's be honest, we all make mistakes. But on the other side, you've got automation. We're talking insane speed, machine-level precision, and a level of quality that's consistent every single time. So, this pushed the entire industry toward a fully automated solution. One of the classic methods is the through-hole assembly line. That just means the little component legs get inserted through holes in the board. When you automate that, it's like watching a perfectly synchronized team of robotic specialists. It's a symphony of machines. All right, let's follow a single blank circuit board as it makes its way through this whole process. It all kicks off with the board loader, which does exactly what it sounds like. It carefully feeds one board after another into the start of this crazy fast production line. Okay, first stop, it meets the absolute beast of the line, the axial inserter. This machine's one job is to handle all the super common components, things like resistors and capacitors. The little guys that lie flat against the board. And I am not kidding when I call it a beast. Get this. These machines are so fast, they can place up to 24,000 components every hour. That's more than 6 every single second. Just wow. So after all the flat components are on, the board keeps moving. Next up is the specialist of the line, the radial inserter. This one's job is to handle all the components that need to stand upright, things like transistors or a lot of LEDs. And this really breaks down the key difference, right? Axial components, they lie flat, parallel to the board. Radial ones, they stand straight up, perpendicular. Two totally different jobs, so you need two totally different specialized machines to get it done right. Okay, so that covers the standard parts. But what about everything else? The big, clunky, or just plain weirdly shaped ones. The stuff that doesn't fit the standard mold. This is where things get really interesting. Yeah, they're called odd-form components. This is the catch-all for everything from huge connectors to custom parts. And they are a massive headache for automation because, well, they're just odd. Standard machines just can't handle them. So who's the hero of this part of the story? Meet the odd-form inserter. You can think of it as the master craftsperson of the robot world. It's an incredibly flexible, super intelligent machine built for this exact challenge. And this machine is just incredible. It's not just flexible, it is fast. A machine like the OIM series from Southern Machinery can pick up a unique part, figure out its orientation, and place it perfectly in less than a single second. And look, this isn't just a cool concept. The proof is in the pudding. Customers who use this kind of automation are seeing huge jumps in efficiency. We're talking over 20% and a massive improvement in the final product quality. It just works. So, okay, we've seen the how, but why? Why go to all this trouble to create these amazing robotic lines? Let's zoom out for a second and look at the big picture logic behind this whole shift to automation. This right here is maybe the biggest reason of all: quality. Automation just absolutely slashes the error rate. You're going from something that can be pretty inconsistent to a defect rate of less than 300 parts per million. That's a level of quality that is just, it's physically impossible to hit by hand. So you've got these core strengths, right? Unbelievable precision, incredible speed, consistent quality. And that lines up perfectly with what the global electronics market needs right now: the ability to grow, to innovate, and to stay competitive.
When you boil it all down, it's not just one thing. It's this killer combination. You get lower costs, you get way faster production, you get a much better and more reliable product, and this is a big one, you get the flexibility to build whatever new gadget comes along next. So where is all this heading? What does it all mean? Because what we're looking at here, this whole robotic revolution, it really is just the beginning.
And that's the key takeaway, isn't it? This isn't just about making today's products a little faster or a little cheaper. No, this is about building the capability, the foundation, to create the next generation of technology that's going to shape all of our lives tomorrow. So next time you grab your phone, or you start your car, or you use pretty much any piece of modern tech, just take a second and think about that invisible, amazing, high-speed robotic ballet that brought its incredible inner world to life.